Hello everybody, myself Jyoti, and today we are going to study physics of semiconductors, and this is lecture 1. Now first is, what are semiconductors? So semiconductors, we all know, they are the materials whose electronic properties are intermediate between those of metals and insulators. We know that metals, they are good conductors, insulators, they are bad conductors. So semiconductors, they are intermediate conductors. Now, on what factors semiconductor property depends? So, semiconducting property of a material depends upon its crystal structure, bonding characteristics, electronic energy bands, and also when we talk about semiconductor, it has both positive and negative carriers of electricity, and we can control the density of this electron and hole by doping pure semiconductor with chemical impurities during crystal growth. So, when we classify the solids with respect to their electrical properties, we talk about generally two materials, metals and insulators. When we talk about metals, they are considered to have a permanent electron gas, and this electron gas, it can move inside the solid, and it is confined within the solid. It cannot come out of the solid. And this electron gas, it can be influenced by electric and magnetic field. This results in the familiar property of metallic conduction. When we talk about insulators, in insulators we have no free electron, and so there is no concept of electron gas in insulators, and there is no electrical conductivity as there is no free electron. When we talk about semiconductors, semiconductors are fundamentally similar to insulators, and they do not form a separate class of their own. We consider it as a part of insulators only, because at absolute zero temperature, when the temperature is very less, at absolute zero temperature, in that case they have the behavior which is just similar to that of insulator. So that is how we have two classes of materials, metals and insulators, and semiconductor, it is also part of a insulator. Now, types of semiconductors. So semiconductors, basically they are of two types. One is intrinsic semiconductor, second one is extrinsic semiconductor. Intrinsic semiconductor, it is also known as pure semiconductor, and extrinsic semiconductor, it is also called as doped semiconductor. Now, intrinsic semiconductors are those in which electrons are and holes are produced by thermal activation, and the example for this is pure germanium and pure silicon. So here in these materials you have a covalent bonds. These covalent bonds get broken at room temperature, and the electrons become free for conduction. In extrinsic semiconductor, the current carriers, holes or free electrons, they are produced by addition of small quantity of elements. So either you have to add group 3 if you have to form p type semiconductor, or you have to add group 5 element if you have to form the n type semiconductor. So these impurities which are added are called as impurities, or they are also called as dopants, and that is why extrinsic semiconductors, they are also called as doped semiconductors. Now let us talk about covalent bonds in intrinsic semiconductor. So certain of the covalent bonds in the pure material must be broken, because if the covalent bonds are not broken, then we will not have free electrons which are required for the conduction, or which are required to carry current. Now here, in case of intrinsic semiconductor, the factor which is responsible for the breaking of the covalent bonds, that is thermal agitation. At absolute zero, the pure semiconductor will behave as an insulator, because no covalent bonds will break at that particular temperature. But as the temperature increases, we know that thermal energy will also increase, because thermal energy depends on temperature, E equals to kT. So as T will increase, temperature will increase, thermal energy will also increase, and that is the way at room temperature, intrinsic semiconductor, they will carry current. Now, when the conductivity in crystalline semiconductor is solely due to breaking of covalent bonds, as in the case of intrinsic semiconductor, they are named as intrinsic semiconductor. But the second case is, in some case, what we have to do, certain atoms are introduced. So either atoms from the third group element or fifth group elements are introduced or doped, so that they become conductors. So that is the extrinsic semiconductor. Now, there are two groups of particles which must be considered in some detail in order to explain adequately the properties of semiconductors. Now, first group is characterized by comparative freedom of motion and is composed of photons, phonons, electrons, and holes. And second group is composed of the so-called imperfections, consist of chemical impurities, defects, and so on. This we are going to study at a later part, not in this video. Now, intrinsic semiconductors which have no impurity, because just now we have studied we are not doping anything here. We are doping in case of extrinsic semiconductor. So these are the semiconductors which have no impurity type of imperfection, but they do have defects. So germanium and silicon in the pure form are two examples of intrinsic semiconductors. And in these cases, there are four nearest neighbors to each atom, and there are two electron bonds between each of the neighbors and the atom. And in intrinsic semiconductor, a forbidden gap exists between a filled valence band and conduction band, but the width of the forbidden gap, which is expressed in energy, is much smaller than that of insulator. In case of insulator, the gap between valence band and conduction band, it is so much that electron from valence band cannot enter to the conduction band, and that is how conduction is not possible. In metals, they just overlap. That is how conduction takes place. But in case of semiconductors, there is a small gap between valence band and conduction band, and when you supply thermal energy, the electron from the valence band, it can go to the conduction band, and current, it can carry current. Now, conduction occurs in an intrinsic semiconductor by thermal excitation of electrons from the valence to the conduction band, as I said. So electrons excited to the higher predominantly empty conduction band levels can move from atom to atom, and thus contributing to conduction when a field is applied to the semiconductor. Now let us talk about conductivity and temperature. Now here we have already discussed that the conductivity of a semiconductor depends strongly on temperature because of the need for thermal energy to excite electrons into the conduction band. Now, as the temperature will increase, more number of covalent bonds will break and more electrons will be free for the conduction. So that is how in a semiconductor, the higher the temperature, the lower the resistivity and more will be the current. And this case is just the reverse as that of in the metals. So this is just introduction about the physics of semiconductors. Thank you. Thank you so much.